Okay, folks, this is our third different way to name chemical formulas or to write the formula given the name. We talked about ionic, we talked about molecular. Today we're going to talk about naming acids. So our objective is, by the time we finish today, you understand, well, maybe not necessarily even today, how about this week, you understand the process of naming acids and the three rules that you need to know to name the acids. Because we have three different rules that we follow when we name acids. Now, first of all, what is an acid? It is a distinct type of a molecular compound. Most acids that are used can be either classified as binary acids or oxyacids. You're going to see coming up that an oxyacid is an acid that has oxygen as well as usually something like nitrogen, phosphorus, sulfur. So, you'll see when we talk about these oxyacids, but most of them, not all, most of them can be either classified as binary or an oxyacid. Binary acids consist of two elements. Usually it's hydrogen with a halogen. Not always the case, but usually. Like I said before, oxyacids contain hydrogen, oxygen, and a third element that is usually a nonmetal. Usually is a nonmetal. The key to being an acid is this general form right here. Whereas H is hydrogen and Y is a monoatomic or a polyatomic anion. So if you haven't already done so, why don't you take out periodic tables, ion sheets? We're going to be using those. So take out your periodic table, take out your ion sheet. So anytime we have something that begins with hydrogen, we're dealing with an acid, with one exception. Actually, I can think of more than one exception. Okay, I can think of a couple. One would be water, H2O. Okay, we do not consider water an acid. Another one would be hydrogen peroxide, H2O2. So there are some exceptions, but the majority of the time, if something begins with hydrogen, it is an acid. So how are we going to distinguish whether something's an acid or not? We look for hydrogen. HCl starts with hydrogen, doesn't it? That is an acid. H2SO3. Here we have an oxyacid because we have hydrogen, we have the oxygen, and we have sulfur, the nonmetal that goes with it. H2SO3, an oxyacid. Here is the first of the 3 acid rules. So go ahead and write down the rule, and then we will discuss it. I want you to look at PAL. I want you to look at PAL, your polyatomic ion list. And I want you to look at all of the endings on PAL. It is either an ATE, an ITE, or an IDE, other than the positive one, which is ammonium. All of the negative ions end in IDE, an ITE, or ATE. Would we agree on that? Well, the 3 acid rules depend on those 3 endings, IDE, ATE, ITE. The first one is the IDE ending. If the anion ends in IDE, the acid name begins with the prefix hydro. Then we take the anion, substitute an IC at the ending, and then follow that by the word acid. So, if I look here, right here, we said HCl. I look at this and I identify this as an acid because it begins with H. So I am immediately thinking, okay, I need my 3 different acid rules. Well, what is Y? Y is chlorine, but as an anion, it is the chloride anion. The chloride anion. So I look and I see, okay, I have an IDE ending. So I'm going to start off with the prefix hydro. Take the stem of the word, the CHL, OR, and then put IC. So this would be hydrochloric acid. Hydrochloric acid. Now what you're going to see most of the time when you have an IDE ending, it's going to be binary. Not all the time, because we still have some polyatomics that have IDE endings. But most of the time, if we have an IDE ending, it's going to be binary. Here is another one, H2S. I recognize this is an acid because it begins with H. What is S as an anion? Sulfide. I see the IDE ending, so I put hydro, the base, and in this time, this is something that you just have to memorize, because if you would just take off the IDE and put on the IC, it would be sulfic. For some reason, people don't think that sounds very fluent, so they put the UR back in there. So they call it hydrosulfuric acid. Just something you have to memorize to put that UR back in there with sulfur. Here is the second acid rule. When the anion ends in ITE, the acid name is the stem of the anion with the suffix OUS followed by the word acid. Here is H2SO3. So if I am looking at my anion, my Y, it is going to be SO3. Find SO3 on your polyatomic ion sheet. What is SO3 and what is SO3's charge? It is a 2 negative charge, and the name of the anion is sulfite. I see sulfite, I see the the ITE ending, so I know that this is rule number 2. I need to add the suffix OUS. So when I come up with my name, it is sulfurous acid. Sulfurous acid. Here is the third acid rule. Our third acid rule depends on the ATE ending. So when an anion ends in ATE, the acid name is the stem of the anion with an IC ending followed by the word acid. Followed by the word acid. So, as I look at this particular example, HNO3, my Y, in this case, my Y is NO3. NO3 on POW is nitrate with a 1- charge. I look at nitrate. I know that the ATE drops, and I put an IC instead. So this is nitric acid. Nitric acid. So, if we review the rules, rule number 1 and rule number 3 both end in IC. What's the difference? The first one what? The first one has hydro. Okay? The first one has hydro. I remember this because I have a little saying. I see 1 or 3. Okay? So if I see and I see, it's either rule number 1, it's rule number 3. Okay? If I don't see an IC, it's rule number 2. Okay? I see a 1 or a 3. Now, let's look at a couple of examples of these. Here is the first one. Now, we are working these backwards now with this one, because I am given a name of an acid And I need to find the formula for that acid. So, as I'm breaking this down, I go back to my rules. Right now, I'm looking at that and I'm saying, I see 1 or 3. Which one am I dealing with here? Rule number 1 or rule number 3? Rule number 3. So, rule number 3 tells me that what ending does the anion have? ATE. So when I'm doing this, I am looking for chlorate. I am looking for chlorate. What is the chlorate ion? ClO3, and what is its charge? 1 minus, correct? Now, we haven't done this yet. We haven't talked about this yet. But the number of hydrogens that go with this corresponds to the negative charge of the anion. Since we only have a 1 minus here, how many hydrogens are we going to need? 1. So, the correct answer for chloric acid is HClO3. HClO3. Yeah, Brittany?
So if there was 2 minus with the H2.
Absolutely. We'll go over one of those. That might be coming up next. Okay? But that is absolutely correct. It is coming up next. The question was, if the anion would have been 2 minus, would I have needed 2 H's? Well, that leads us in, well, not this one, but yes, you're going to see this. It's not going to be 2 H's, but you're going to see that Brittany's question will be answered right here. Phosphoric acid. IC 1 or 3. Okay? IC 1 or 3, what rule? Number 3. So what am I looking for here? Phosphate. What is phosphate? PO4 charge 3 negative. So, knowing this is 3 negative, how many hydrogens am I going to need? 3. Okay, so I have H3PO4. Can I leave that 3 negative there? Absolutely not. We don't put negatives on there. So, phosphoric acid is H3PO4. Now, just another note here. Just a side note. That OR right there. Remember I told you the UR was sulfur? Phosphate does that too. Because if you were doing the IDE ending, you'd call this phosphide. Okay? You call this phosphide. But when we name the acid, we put that OR back in there as phosphoric. So make a note of that it is the same thing like sulfur was. If you put phosphic, you think WebAssign's going to agree with you? Not probably. It won't. It'll count it wrong. Now let's look at writing a name. Okay? How do I identify this as an acid? Starts with hydrogen. So, I identify it as an acid I immediately say I need to know what my anion is. In this instance, what is my anion? Nitrite. Find it on your ion sheet. It should be NO2 minus 1. Nitrite. So what acid rule am I dealing with here? Acid rule number 2, an ITE ending. Acid rule number 2 says that if I have an ITE ending, I replace the ITE with what? OUS, and add the word acid. What if I wouldn't add the word acid? What if I just had nitrous? It's not right. It's not right. Here is, I believe, our final example. HBr. Once again, how do I know that I'm identifying an acid? Begins with hydrogen. So I need to look at my anion. What is my anion in this instance? Bromide, right? Bromide. So if I have bromide, right? If I have bromide, what rule am I dealing with? Rule number 1, correct? Rule number 1 tells me to do what? Put hydro in front, replace the IDE with IC, and add the word acid. So HBr would be hydrobromic acid. Yeah, Brooke? Okay, how did we get bromide instead of bromite? Bromate, okay? Bromate are going to be, bromate is, I think, BrO3, 1 minus. Okay, find bromate on your ion sheet, polyatomic, on your PAL. It should be there. Bromate, BrO3, negative 1. Now, you know what bromite is? BrO2, negative 1. Okay? So, we're looking at what simply the anion, what Y is. And Y is whatever the hydrogen is not. Take away hydrogen, and then you'll have the Y. So, what you were asking here is if I were to have, how do I know? I would be looking at something like this, Brooke, HBrO3. And then I would say, oh, that's bromate. Okay, that's bromate. Brittany? You could have to use both of them, okay? You could even use your periodic table, too. Bromide? Yeah. You could even use, well, bromide's not a polyatomic. That's why it's not on PAL. Okay, PAL only has polyatomics. Okay? Now,